And so I'll work through these U substitution examples, but I would say of much more value than just watching someone else do them is for you to try them yourself. So I would recommend definitely doing these examples before watching the video and then seeing how your answer compares to mine once you finish. All right, so now that you've paused the video and done this, now you can see how I did it. The nice rule of thumb here that you almost always can get away with is whatever's inside the parentheses, that's a good U value. Right? That's going to be the argument that never changes. So that 2x squared minus 7 is in the final, so it should be in the initial as well. Right? When I say the final, I mean the answer once you take the derivative, and the initial being the function before you take the derivative. Remember that all of these are just reversing the process of differentiation. Anyway, the derivative of u with respect to x is 4x, and then that means that du over 4x equals dx. If I just multiply both sides by dx and divide both sides by 4x, I'm going to get dx equals du over 4x. So I can rewrite this integral as 4x on the top divided by not this whole thing squared. I'm just going to call it u squared. And instead of dx, I'm going to replace dx with du over 4x. And just like in that example at the end of the last video, the 4x and the 4x are gone, like the noble gas argon, and we just have 1 over u squared, which can be rewritten as u to the negative 2 with respect to u. And then inverse power rule tells us to bump this up by 1, so negative 2 plus 1 is negative 1. Divide by negative 1, which is the same as multiplying by negative 1. And then you've got your constant of integration, and your final answer would be negative 1 over 2x squared minus 7 plus c. And again, this is something you can and should check with differentiation. Take the derivative of your answer, and you should get back to your original integrand. Keeping on here, we're going to take a look at this x squared plus 1. X squared plus 1 would be a good u value. It's inside the implied parentheses, right? This is x squared plus 1 parentheses raised to the 1/2 power in the denominator, just like this was raised to the 2 in the denominator. Basically the same sort of problem. So du dx equals 2x. So if you multiply by dx and divide by 2x, you get du over 2x equals dx. So when you do your u substitution, you've got an x on the top, and you've got a square root of u on the bottom, or u raised to the 1/2 on the bottom. And then the dx is going to be replaced with du over 2x. And here something a little bit different happens. Up until now, the coefficient always canceled out along with the variable. I don't really care about whether this coefficient cancels out or not. I'm going to have to keep track of it if it doesn't cancel out, but I don't care whether it's there or not because it's not going to make the integration any harder. The x's are gone, and that part is essential. We have to get rid of all of our x's. So that, remember, the goal is to rewrite our integral in terms of a new variable, and that new integral should be easier to deal with than the original one. So this 2 in the denominator is a constant that I can just factor out. So I've factored that out. The 1 over u to the 1/2 can be rewritten like this, and then the du is essential there as well. And then this is a very routine problem. We'll just take that u raised to the negative 1/2. We've got to bump that exponent up by 1, so it's going to bump up to 1/2, and then we're going to divide by 1/2, which is the same as multiplying by 2. And this is actually quite nice because then the 2 and the 1/2 are gone, like the noble gas are gone, and we have u raised to the 1/2, or the square root of x squared plus 1 plus c. So that's kind of an interesting problem. You don't expect that when you start seeing the 1/2 out front, you're expecting to see a 1/2 in your answer, but actually another thing happens to make this whole thing cancel out. So yeah, pretty good problem. Make sure you know how to do that one. All right. So when we look at this one, we say, well, we've always set the denominator equal to u, but it doesn't have to be the case. The better thing to set equal to u is the thing inside the parentheses. So I'm going to write this 1 plus 1 over x cubed, but I'm going to write it as x raised to the negative 3. Of course, that makes it easier to use the power rule. So du with respect to x is negative 3x raised to the negative 4. So I'm going to divide by negative 3x to the 4th. I'm going to multiply by dx. I'm going to get du over negative 3x to the negative 4 equals dx. Now I'm going to take this one step further, and I'm going to rewrite this as du on the top and a negative 3 on the bottom. And then that x to the negative 4, bring that up to the top. Change it to an x to the positive 4. You don't have to do it that way, but it's kind of nice to do it now rather than looking at negative exponents. I try to avoid negative exponents when they're in an answer. One thing that people will often do, so be careful not to do this, people will often say, oh, that negative 3 needs to go up to the top as well. But it doesn't. The negative 3 stays on the bottom. The negative 3 isn't being raised to a negative exponent. It's only the x that's being raised to the negative exponent. So let's make sure that we're only moving things that are supposed to be moved. Anyway, either one of these two expressions are reasonable expressions to use for dx. I just prefer the one on the right. So when we rewrite this integral, I'll rewrite the numerator as u squared. I'm not going to mess with the denominator x to the 4th yet because I see what's going to happen in a minute. We've got x to the 4th over here times du over negative 3. Remember, this fraction right here is the same thing as dx. We're just replacing it with something that it equals. And as always, what must happen at this stage is all of your variables of the original variable have to go away. Otherwise, we've either made a mistake or we've got more work to do. Maybe we picked the wrong u value. But when we see this happen, we're happy. Again, the negative 3 is a constant, so I'll factor that out. I don't need that messing up my integral. And I've got u squared du. Which, again, the whole goal is to get those integrals that are in a very simple form so we can just do that integration without much trouble. So the 2 bumps up to a 3, and we're going to divide by 3. Don't assume that everything's always going to cancel out. On the last problem, everything canceled out, so we had a coefficient of 1. This time, that's not the case. We're going to get negative 1/9 times u cubed, where u is 1 plus 1 over x cubed. So we're going to take that and raise it to the 3rd power. And we won't forget our constant of integration. Fantastic. Tune in next time when we introduce trig to the mix.